Welcome, geometry students, to section 2.2 about proving lines are parallel. So what we're going to look at in this section is the converse of the theorems and the postulate that we looked at in the last section. So if you remember, a converse is where we switch, right, or interchange hypothesis and conclusion. So if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So an example from this diagram, if I want a pair of corresponding angles, I guess I'll go with 2 and 6. So if let me start over again. If angle 2 is congruent to angle 6, then we'll call these A and B. Line A is parallel to line B. If two lines are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. So if we go with, let's say, 3 and 5. So if angle 3 is congruent to angle 5, then A is parallel to B. Alternate exterior angles converse. So if two lines are cut by a transversal so that alternate interior or exterior angles are congruent, then the lines are parallel. So let's go with 1 and 7. So if angle 1 is congruent to angle 7, then A is parallel to B. And lastly, our consecutive interior angles converse. So now this one says if two lines are cut by a transversal so that consecutive interior angles are supplementary, then the lines are parallel. So let's go with angles 4 and 5. Okay, so if angle 4 and angle 5 are supplementary, I'm going to abbreviate, then A is parallel to B. Okay, so now we can use these theorems to determine which lines are parallel, okay, and to prove that lines are parallel. So in this activity, I want you to go through A through K and determine which lines are parallel. I'll help you get started. So if we're looking at 2 and 4, and 2 and 4 are congruent, then I want to first identify the transversal. 2 and 4 are both attached to A. So if A is the transversal, that would make these two lines the parallels. So that means C is parallel to D. And then what type of angles are these? If you said corresponding, that's correct. So that would be the converse of corresponding, again abbreviating, angles theorem. Or you can say corresponding angles theorem converse. You can write it out either way. Okay, so go ahead and try the rest of these. Pause the video, and when you're done, come back and we'll compare answers. Okay, so let's see how you did. Go through and check your answers. Pause the video again. If anything that you have is different, put a little star next to it or highlight it, and then you can ask in class. Okay, our next theorem, Theorem 2.8, and do not worry about memorizing theorem numbers. That's not something I'm ever going to ask you. And to be honest, those numbers only apply to this text. If you open up another geometry book, chances are the number will not be the same. So the important thing is what the theorem actually says. So if two lines are parallel to the same line, then they are parallel to each other, okay, which makes sense, right? We have these two lines are parallel and these two lines are parallel, then I know that the last pair of lines is parallel, okay, meaning these two. And the next theorem, if two lines are perpendicular to the same line, then they are parallel to each other, which again makes sense. If they're perpendicular to the same line, then that means we have all right angles here. So really we could use any of our new converses to prove that A is parallel to B. Okay, here's another type of proof. It's called a flow proof. We're going to prove the converse of the alternate interior angles theorem, which means we're going to be given that 1 and 2 are congruent, and we're going to use another one of our theorems to get to the point where we can say that L is parallel to M. So that means somehow I'm going to want to use angles 2 and 3, right? If I can get 2 and 3 are congruent, what kind of angles are 2 and 3? If you said corresponding, that's correct. So I can use the converse of the corresponding angles theorem to say that the lines are parallel. So that's our goal. So I have to figure out a way to connect 2 and 3. Okay, knowing that 1 and 2 are congruent. So take a look at the diagram. If you're thinking vertical angles, that's a good start, right? And that is how we're going to start. So here's what the flow proof looks like. We're going to start off with the given. We put it usually in a box. And under the box, we put the reason. So we know 1 is congruent to 2 from the given. And then we're using vertical angles to say 1 is congruent to 3. That leads us to where we can say angle 2 is congruent to angle 3. And that comes from the transitive property. So here's a good example of when you could not use substitution. If you were thinking substitution, remember that's only a property of equality. If we're using congruency, then it has to be transitive. Now we're at the point, this is a very short proof, as you can see. We're at the point where we're saying 2 is congruent to 3, so we can use our converse of the corresponding angles theorem and say that the lines are parallel. So write a flow proof for theorem 2.6, which is the converse of the same side interior angles postulate. So we're given that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees, and we're asked to prove that these two lines are parallel. So I gave you a couple of pieces to get started. Obviously the given, and then you can use the fact that angle 1 plus angle 3 is equal to 180, and that's from the linear pairs theorem. So see what you can do from there. Pause the video, and then when you come back, we'll compare and see how you did. Okay, let's take a look. So the next thing I did is group these together, right? Did a substitution, replaced 180 with one of the sums, if you want to look at it that way. You could have also said transitive property, that would be okay. So our next line, we can use the subtraction property to say the measure of angle 2 is equal to the measure of angle 3. Okay, and then the next thing, you may say, well, aren't we done? Because now we have 2 congruent to 3. But this is equality. Right? Remember, the theorems are written where we say that the angles are congruent. Okay, so we need one more step. And notice here too that this was congruency, not equality. So we need one more step where we say that, oh, and I didn't put mine in boxes. I'm gonna put little boxes around these. That angle 2 is congruent to angle 3. And do you remember the reason for that? That's the definition of congruence. And then lastly, we can say that angle L, or line L, is parallel to line M, and that would be based on the theorem for this angle pair, which is the corresponding angles converse. Okay, let's see what's next. Okay, so here we have angle 1 and angle 2 form a linear pair, and angle 4, or angle 1 and angle 4 are supplementary. So prove A is parallel to B. So again, I want you to pause the video, go ahead and give this a try, and when you're done, come back. You'll see there's a lot of repeated patterns in these. So just look at what we've done previously, give it a good shot, and when you're done, come back and we'll compare. Okay, so here's the reasons. We're going to fill in, here's the statements. We're going to fill in the reasons together. So always start off with the given. Okay, stated all of it in one statement. From the fact that 1 and 2 form a linear pair, I can say that the angle measures add up to 180. If you need to stop and pause and fill in these statements, go ahead. Okay, so since that, again, I'm explaining what it means to be a linear pair, that's the definition. Okay, in the next line, because 1 and 4 is supplementary, I can say the sum of those angles is 180. And I'm using another definition. The definition of supplementary angles. Here's that repeated pattern we've been seeing. If they both equal 180, then they equal each other. So again, this could be substitution or transitive. I guess I'll go with transitive this time. Property of equality. From subtraction, I can say the measure of angle 2 is equal to the measure of angle 4. I have that middle step, because remember I need congruency to use the theorem. So that's the definition of congruency. And then lastly, I'm using the converse of the corresponding angles theorem. Okay, so you've seen me write this 2 different ways. I think last time I did corresponding angles converse, or converse of corresponding angles theorem. I would accept either way. Okay, I think we have one more. So here you're given that the measure of angle 2 plus the measure of angle 3 is 180. You're given that angle 2 and angle 5 are supplementary. And you're asked to prove that P is parallel to Q. So go ahead and give that a try. Pause the video. Come back when you're done. Okay, let's see how you did. So there's all the statements and reasons. And again, you can see we're using a lot of the same repeated ideas here. Just at the end, you have to look and see, okay, what am I dealing with? I've got angles 3 and 5, which are alternate interiors. So I'm using the converse of the alternate interiors angles theorem. So that concludes our lesson for 2-2. I hope you enjoyed it, and I will see you in class. Have a good day.